11th, let's start the chapter 9, that is motion and time. In class 6, you have learned about different types of motions. You have learned that a motion could be along a straight line. It could be a circular or periodic. Can you recall these three types of motion? Table 9.1 gives some example of motions. Identify the type of motion in each case. It is a common experience that the motion of some object is slow while that of some object is fast. Slow or fast. You know that some vehicles move faster than others. Even the same vehicle may move faster or slower at different times. Make a list of 10 objects moving along a straight path. Group the motion of these objects as slow and fast. How did you decide which object is moving slowly and which object is moving fast? If vehicles are moving on a road in the same direction, we can easily tell which one of them is moving faster than the other. Let us look at the motion of the vehicles moving on a road. Activity 9.1. Look at the figure 9.1. It shows the position of some vehicle moving on a road in the same direction at some instant of time. Now look at the figure 9.2. It shows the position of same vehicle after some time. For your observation of the two figures, answer the following question. Which figure is moving the fastest of all? Which one of them is moving the slowest of all? The distance moved by the object in a given interval of time can help us to decide which one is faster or slower. For example, imagine that you have gone to see of your friend at the bus station. Suppose you are starting pedaling your bicycle at the time as the bus begins to move in. The distance covered by you after 5 minutes would be much smaller than the covered by the bus. Would you say that the bus is moving faster than the bicycle? We often say that the faster vehicle has a higher speed. In a 100-meter race, it is easy to decide whose speed is the highest. One who takes the shorter time to cover the distance of 100 meters has the highest speed. Speed, you are probably familiar with the word speed. In the example given above, a higher speed seems to indicate that a given distance has been covered in a shorter time or a larger distance covered in a given time. The most convenient way to find out which one of the two or more object is moving faster is compare the distance moved by them in a unit time. Thus, if we know the distance covered by two buses in 1 hour, we can tell which one is faster. We call the distance covered by an object in a unit time as the speed of the object. When we say that a car is moving with a speed of 50 kilometers per hour, it implies that it covered with a distance of 50 kilometers in 1 hour. However, a car seldom moves with a constant speed for 1 hour. In fact, it starts moving slowly and then pick up speed. So when we say that the car has a speed of 50 kilometers per hour, we usually consider only the total distance covered by it in 1 hour. We do not bother whether the car has been moving with a constant speed or not during that hour. The speed calculated here is actually the average speed of the car. In this book, we shall use the term speed for average speed. So for us, the speed is the total distance covered divided by the total time taken. Thus, speed का formula होगा total distance by total time taken. In everyday life, we seldom find objects moving with a constant speed over a long distance or for a long duration of time. If the speed of object moving along a straight line keeps changing, its motion is said to be non-uniform. On the other hand, an object moving along a straight line with a constant speed is said to be uniform motion. In this case, the average speed is the same as the actual speed. We can determine the speed of a given object once we can measure the time taken by it to cover a certain distance. In class 6, you have learned how to measure distance, but how do we measure time? Let's find out. Measurement of time. If you did not have a clock, how would you decide what time of day it is? Have you ever wondered how our elder could tell the appropriate time of day by just looking at the shadow? How do we measure the time interval of a month or a year? Our ancestors noticed that many events in nature repeated themselves after definite interval of time. For example, they found that sunrise every day in the morning. The time between one sunrise and the next was called a day. Similarly, a month was measured from a one next moon to the next. A year was fixed as the time taken by the earth to complete one revolution of the sun. Often we need to measure interval of time which are much shorter than a day. A clock or watch are perhaps most common time measuring device. Have you ever wondered how clock and watches measure time? The working of clock is rather complex, but all of them makes use of some periodic motion. One of the most well-known periodic motion is that of a simple pendulum. A simple pendulum consists of a small metallic ball or a piece of stone suspended for a rigid stand by a thread. The metallic ball is called the bob of the pendulum. Shown the pendulum at the rest is mean position. When the bob of the pendulum is released after taking it slightly to one side, it begins to move to and fro. The to and fro motion of a simple pendulum is an example of periodic or an oscillatory motion. The pendulum is said to have complete one oscillation when its bob starting from its mean position O moves to A to B and back to A. The pendulum also complete one oscillation when its bob moves from one extreme position A to the other extreme position B and come back to A. The time taken by the pendulum to complete one oscillation is called its time period. Activity 9.2. Set up a simple pendulum as shown in figure 9.a with a thread or string of a length nearly 1 meter. Switch off any fans nearby. Let the bob of the pendulum come to the rest as its mean position. Mark the mean position of the bob on the floor below it or on the wall behind it. To measure the time period of the pendulum, we will need a stopwatch. However, if a stopwatch is not available, a table clock or a wristwatch can be used. To set the pendulum in motion, gently hold the bob and move it slightly to one side. Make sure that the string attached to the bob is taut while you displace it. Now release the bob from its displaced position. Remember that the bob is not to be pushed when it is released. Note the time on the clock when the bob is its mean position. Instead of mean position, you may note the time when the bob is at one of its extreme position. Measure the time the pendulum takes to complete 20 oscillations. Record your observation. Table 9.2. The first observation shown is just a sample. Your observation could be different from this. Repeat this activity a few times and record your observations. By dividing the time taken for 20 oscillations by 20, get the time taken by one oscillation or the time period of the pendulum. Is it the time period of your pendulum nearly the same in all cases? Note that a slight change in the initial displacement does not affect the time period of your pendulum. Nowadays, most clock or watches have an electric circuit with one or more cells. These clocks are called quartz clocks. The time measured by quartz clock is much more accurate than by the clock available earlier. Unit of time and speed. The basic unit of time is second. Its symbol is small s. Large unit of time are minutes, that is represented by bracket में min, and hours represented by h. You already know how these units are related to one another. What would be the basic unit of speed? Since the speed is distance by time, the basic unit of speed is meter per second. Of course, it could also be expressed in other units such as meter per minute or kilometer per hour. You must remember that the symbol of all the units are written in singular. For example, we write 50 kilometers, not 50, or 8 centimeter, not 8 centimeters. Bujo is wondering how many seconds there are in a day and how many hours in a year. Can you help him? There is an interesting story about the discovery that the time period of a given pendulum is constant. You might have heard the name of famous scientist Galileo Galilei, AD 1564 to 1642. It is said that once Galileo was sitting in a church, he noticed that a lamp suspended from the ceiling with a chain was moving slowly from one side to other. He was surprised to find out that this pulse beat the same number of times during the interval in which the lamp completed one oscillation. Galileo experimented with the same various pendulums to verify his observation. He found that the pendulum of given length take always the same time to complete one oscillation. This observation leads to development of pendulum clock, winding clock, and wristwatches, where refinement of the pendulum clock. Different units of time are used depending on the need. For example, it is convenient to express your age in year rather than in days or hours. Similarly, it is not be wise to express in year the time taken by you to cover the distance between your home and your school. How small or large is the time interval of 1 second? The time taken in saying aloud 2001 is nearly 1 second. Verify it by account aloud for 2001 to 2010. The pulse of a normally healthy adult at rest beats about 72 times in a minute, that is about 12 times in 10 seconds. This rate may be slightly higher for children. Paheli wondered how time was measured when pendulum clock was not available. Many times measuring a device were used in different parts of the world before the pendulum clock became popular. Sundial, water clock, and sand clock are some examples of such devices. Different designs of these devices were developed in different parts of the world, measuring speed. Having learned how to measure time and distance, you can calculate the speed of an object. Let us find the speed of a ball moving along the ground. Activity 9.3. Draw a straight line on the ground with a chalk, powder, or a lime and ask one of your friends to stand 1 to 2 meters away from it. Let your friend gently roll a ball along the ground in a direction perpendicular to the line. Note the time at the moment the ball crosses the line and also when it comes to rest. How much time does the ball take to come to rest? The smallest time interval that can be measured with a commonly available clock and watches is 1 second. However, now special clocks are available that can measure time interval is smaller than 1 second. Some of these clocks can measure time interval as small as 1 billionth or even 1 billionth of a second. You might have heard the term like microsecond and nanosecond. 1 microsecond is 1 millionth of second, and 1 nanosecond is 1 billionth of second. Clocks that measure such small time interval are used for scientific research. The time measuring device used in sport can measure time intervals that are 1/10 and 1/100 of a second. On the other hand, the times of historical events are stated in terms of centuries or millenniums. The age of stars and planets are often expressed in billions of years. Can you imagine the range of time interval that we have to deal with? Measure the distance between the point at which the ball crosses the line and the point where it comes to rest. You can use a scale or a measuring tape. Let different groups repeat the activity. Record the measurement in 9.3. In each case, calculate the speed of a ball. You may know, like to compare your speed of walking or cycling with that of your friends. You need to know the distance of the school from your home or from some other point. Each one of you can measure the time taken to cover the distance and calculate your speed. It may be interesting to know who among you is the fastest. If speeds of some living organisms are given in Table 9.4 in kilometer per hour. You can calculate the speed in meter per second yourself. Rocket launching satellite into Earth's orbit often attains speed up to 8 kilometers per second. On the other hand, a tortoise can move only with a speed of 8 centimeter per second. Can you calculate how fast is the rocket compared with the tortoise? Once you know the speed of an object, you can find the distance moved by it in a given time. All you have to do with it multiply the speed by time. Thus, distance is covered is equal to speed into time. You can also find the time an object would take to cover a distance while moving with a given speed. Time taken is equals to distance by time. Bujo wants to know whether there is any devices that measure the speed. You might have seen a meter fitted on a top of a scooter or motorcycle. Similarly, meter can be seen on the dashboard of car, buses and other vehicles. Show the dashboard of car. Note that one of the meter has kilometer per hour written at one corner. This is called speedometer. It records the. So here is the table which is given, and in this table we can see some animals and their speed. Like falcon, its speed is 320 kilometer per hour. Cheetah is 112 kilometer per hour. Blue whale, blue fish is 40 to 56 kilometer per hour. Rabbit is 56. Squirrel is 19. Domestic mouse is 11. Human is 40. Giant tortoise can point to 7 kilometers per hour. Snail is 0.05 kilometers per hour. So here kilometers per hour can be changed in meter per second also. You can change it according to this way. Speed directly in kilometer per hour. There is also another meter that measures the distance moved by the vehicle, and this meter is known as odometer. While going for a school picnic, Paheli decided to note the reading on the odometer of the bus after 30 minutes till the end of the journey. Later on, she recorded her reading in table 9.5. Can you tell how far was the picnic spot from the school? Can you calculate the speed of the bus? Looking at the table, Poocho asked Paheli whether she can tell how far they would have traveling till 9:45 a.m. Paheli had no answer to this question. They went to their teacher. She told them that one way to solve this problem is to plot a distance time graph. Let us find out how such graph is plotted. Distance time graph. You might have seen that newspaper, magazines, etc. present information in various forms of graphs to make it interesting. The type of graph shown in figure 9.8 is known as bar graph. Another type of graphical representation is pie chart. The graph shown in figure 9.10 is an example of line graph. The distance time graph is a line graph. Let us learn to make such a graph. Take a sheet of graph paper. Draw two lines perpendicular to each other on it, as shown in figure 9.11. Mark the horizontal line as x o x dash. It is known as the x-axis. Similarly, mark the vertical line y o y. It is called y-axis. The point of intersection of XOS and YOY is known as the origin, O. The two quantities between which the graph is drawn are shown along with these two axes. We show the positive value on the x-axis along OX. Similarly, positive value on the y-axis are shown along OY. In this chapter, we shall consider only the positive value of the point. Therefore, we shall use only the shaded part of the graph shown in figure 9.1. Bujo and Paheli find out the distance traveled by a car and the time taken by it to cover that distance. Their data is shown in table 9.6. Make the graph by following these steps given below. Draw two perpendicular lines to represent the two axes and mark them as OX and OY as figure in 9.11. Decide the quantity to be shown along the x-axis and that to be shown by along the y-axis. In this case, we show the time along the x-axis and along distance along the y-axis. Choose a scale to represent a distance, another to represent the time on the graph. For the motion of the car, scale could be time 1 minute is equals to 1 centimeter, distance is equals to 1 minute is equals to 1 centimeter. For the time and the distance on the respective axis according to the scale you have chosen. For the motion of the car, mark the time 1 minute, 2 minutes and on the axis from the origin O. Similarly, mark the distance 1 kilometer, 2 kilometer on y-axis. Now you have to mark the points on the graph paper to represent each set of value for a distance and time. Observation record at S on number 1 table 9.6 shown that at the time 0 minute the distance moved is also 0. The point corresponding to this set of value on the graph will therefore be the origin itself. After 1 minute the car has moved a distance of 1 kilometer. To mark this set of values, look for the point that represent 1 meter on x-axis. Draw a line parallel to the y-axis at this point, then draw a line parallel to the x-axis from the point corresponding to distance 1 kilometer on y-axis. The point where these two lines intersect represent this set of values on the graph. Similarly, mark on the graph paper the points corresponding to different set of values. Figure 9.12 shows the set of points on the graph corresponding to the position of the car at the various times. Join all the points on the graph as shown in figure 9.13. It is a straight line. This is the distance time graph for the motion of the car. If the distance time graph is a straight line, it indicates that the object is moving with a constant speed. However, if the speed of the object keeps changing, the graph can be of any other shape. Generally, the choice of scale is not as simple as in the example given in figure 9.12 and 9.13. We may have to choose two different scales to represent the desired quantity on x-axis and the y-axis. Let us try to understand this process with an example. Let us again consider the motion of the bus that took Paheli and her friends to the picnic. The distance covered and the time taken by the bus as shown in table 9.5. The total distance covered by the bus is 80 kilometers. If we decided to choose a scale 1 kilometers is equals to 1 centimeter, we shall have to draw an axis of length 80 centimeter. This is not possible on the sheet of paper. On the other hand, a scale 10 kilometers is equals to 1 centimeter would require an axis of length only 8 centimeter. This scale is quite convenient. However, the graph may cover only a small part of the graph paper. Some of the points to keep in mind while choosing the most suitable scale for a drawing graph are the difference between the highest and the lowest value of each quantity, the intermediate value of each quantity so that the scale chosen it is convenient to mark the values of the graph values on the graph ends. To utilize the maximum part of the paper on which the graph is to be drawn, suppose that you are given a graph paper of size 25 centimeter to 25 centimeter. One of the scale which meets the above condition can be accommodated. The data table of 9.5 could be distance is equals to 5 kilometers is equals to 1 centimeter and time is equals to 6 minutes is equals to 1 centimeter. Can you now draw the distance time graph for the motion of the bus? Is the graph drawn by a similar to that shown in figure 9.13? Distance time graph provided a variety of information about the motion. When compared to the data presented by a table, for example, table 9.5 gives information about the distance moved by the bus only at some definite time interval. On the other hand, for the distance time graph, we can find the distance moved by the bus at the same instance of time. Suppose we want to know how much distance the bus had traveled at 8:15 a.m. We mark the point corresponding to the time 8:15 a.m. on the x-axis figure 9.14. Suppose this point is A. Next, we draw a line perpendicular to the x-axis or parallel to the y-axis at a point when we mark that point T on the graph at which this perpendicular line intersected. Next, we draw a line through the point T parallel to the x-axis. This intersection the y-axis at the point B. The distance corresponding to the point B on the y-axis of OB gives the distance in kilometer covered by the bus at 8:15 a.m. How much distance? How much is the? How much is this distance in kilometers? Can you now help Paheli to find the distance moved by bus at 9:45 a.m.? Can you also find the speed of the bus from its distance time graph? Now it comes to the last part of the chapter, that is summary. The distance moved by an object is in a unit time is called its speed. Speed of object help us to decide which one is moving faster than the other. Speed of an object is the distance traveled divided by time taken to cover that distance is a basic unit in meter per second. Periodic events are used for the measurement of time. Periodic motion of pendulum has been used to make clock and watches. Motion of object can be presented in pictorial form by their distance time graph. The distance time graph for the motion of an object moving with a constant speed is a straight line.